So for today's video, we will discuss about one of the diode models, which is the ideal diode mode. So when we say forward bias, bias is the application of a DC voltage to a diode to make it either conduct or block current. Forward bias is the condition that allows current through the PN junction. This external bias voltage is designated as V bias. The resistor limits the forward current to a value that will not damage the diode. In the forward bias, the negative side of V bias is connected to the N region of the diode and the positive side is connected to the P region. And in the ideal diode mode, when the diode is forward biased, it ideally acts like a closed switch, which is on switch, as shown in the figure. On the reverse bias is the condition that essentially prevents current through the diode. A DC voltage source connected across a diode in the direction to produce reverse bias. The positive side of B bias is connected to the N region of the diode and the negative side is connected to the P region. Also note that the depletion region is shown much wider than in forward bias or equilibrium. The positive side of the bias voltage source pulls the free electrons away from the PN junction. So in the ideal diode mode, when the diode is reverse bias, it ideally acts like an open switch or off switch, as shown in the figure. The barrier potential, the forward dynamic resistance, and the reverse current are all neglected. Now we will do a circuit of the ideal mode that composed of one resistor, one diode, and one diode LED, and we will charge it 5 volts. So in this case, we need to compute for the value of the resistor. So I LED, which is 20 milliamps. So for the voltage LED is 2.5 volts. So VF minus IR minus V LED is equal to 0. So 5 volts minus 20 milliamps minus 2.5 volts equals to 0. 5 minus 2.5 volts over 20 milliamps. So we calculate for the resistor is equal volts over current equals to 20 milliamps. So we divided it for 20 milliamps.